In this video, we give you an overview of the Streaming Terraform provider and how it simplifies pipeline management at scale. We'll walk through how to define pipelines and shared configurations in Terraform, using Terraform to create, update, and delete pipelines more efficiently. So in this video, we're looking at the Streaming Terraform provider. Currently, managing pipelines requires you to manually navigate to the Streaming tab and add each pipeline individually. Before that, there is a prerequisite. You must create a streaming runner. Once you have filled in the details on the Create Streaming Runner page, you are provided with a client ID, client secret, and runner ID, which you then use to deploy your runner container. Once the container is running, you return to the UI to create the pipeline. You fill in the details here and you select your active runner, define your source and target information, validate the connection, and pick your tables. While this works for a handful of pipelines, it becomes cumbersome and tedious to manage as you scale your infrastructure up. So to solve this, we previously released API endpoints to manage the pipeline lifecycle. We have since built the Streaming Terraform provider as an extension of those capabilities. So looking at this demo configuration, I have a pipelines file defining SQL Server to Snowflake and Postgres to Snowflake integrations. In this scenario, we have multiple pipelines that are nearly identical, with the only differences being the specific tables selected for each. I am using a locals file to define sources like SQL Server and Postgres, along with a Snowflake target configuration. In this pipelines object, I define each individual pipeline. This includes the Snowflake stage prefixes, the specific table sets, and unique fields like the slot name required for the Postgres configuration. I've also added a field called Deploy Agent. This allows me to control whether an agent is actually deployed to AWS. For this demo of 30 pipelines, I don't actually want all 30 active agents running, which is why I added this. You can see here how the pipeline file references those values from the local files. We also have an agent file. This iterates through the pipeline list to automatically create the appropriate agent. Once created, we can extract the client ID and secret for each agent and inject those credentials directly into the containers we are deploying in AWS. Running a Terraform plan shows 69 resources to be added, roughly 30 pipelines, 30 agents, and the associated AWS configuration. Now we apply the configuration, and as you can see, all resources have been successfully added. If we go back and refresh the page, all the new pipelines are visible, including the Postgres and SQL Server to Snowflake integrations. Checking the Runners tab, we can see that all the corresponding runners have been created correctly as well. Now, if we were to have a requirements change, for example, if a table name changes from employees to employee, we simply update the configuration file. Running Terraform plan again highlights this specific change clearly. So now if I update and then return to the pipeline settings, we can see the table name has been updated to the singular employee. Deleting a pipeline is just as simple. We just remove it from the config, run Terraform plan, and then run Terraform apply. Once the apply is finished, the resources are gone. If I refresh the page, we can see that SQL Server 01 has been deleted. Looking at the Postgres 01 pipeline, we can see the runner is running and all configurations were set correctly and runners are running. That covers the basics of creating, updating, and deleting operations for pipelines and runners using the Terraform provider. If you want to learn more, visit maya.ai.